Hello everyone, welcome back to my channel. Myself is Arun Kashish. In this video, we are going to discuss some numericals on projectile motion. In the first question, a projectile is thrown with a speed u, making an angle theta with the horizontal at t is equal to 0. It just crosses 2 points at equal height at t is equal to 1 second and t is equal to 3 seconds. Now we have formula for vertical distance as y is equal to u sin theta t minus half gt square. Put t is equal to 1 and t is equal to 3. We get h is equal to u sin theta into 1 minus half g into 1 square. And similarly for t is equal to 3, we have h is equal to u sin theta into 3 minus half g into 3 square, which is 9. Now solving the two equations, we get 3u sin theta minus u sin theta is 2u sin theta is equal to 4g. This implies u sin theta is equal to 2g. Now using the formula for maximum height, we get h is equal to u sin theta whole square, which is 2g whole square upon 2g. So it is equal to 2g, which is 2 into 10, that is 20 meters per second. Next question. In this question, a stone is to be thrown so as to cover a horizontal distance of 3 meters. So this we are given r is 3 meters and velocity is 7 meters per second. Put the values in the formula of r. We get 3 is equal to 7 square is 49 sin 2 theta upon g is 9.8. So cancelling this, 49 5 we get. This implies 3 upon 5 is equal to sin 2 theta, and sine of 37 degrees is 3 upon 5. Therefore we have 2 theta is equal to 37 degrees or 180 minus 37 degrees, because sine of 180 minus theta is also sin theta. So this implies theta is equal to half of 37 degrees, which is 18.5 degrees, or half of 143 degrees, which is 71.5 degrees. We have two answers for this. In the next problem, we are given that a boy is standing at 78.4 meters from a building and throws a ball which just enters a window. Therefore, here the maximum height h is 39.2 meters and the horizontal range r from this figure is twice of 78.4 meters. Now using the formula of r and h, and on dividing, we have r upon h is equal to 4 cot theta. Therefore r is 2 into 78.4 upon h is 39.2 equals to 4 cot theta. This implies, on cancelling, we get this cot theta is equal to 4 upon 4, which is 1, So this means theta is 45 degrees. Cot 45 degrees is 1. Now put the value of theta in the formula of r. We have r is 2 into 78.4 equals to u square. Sin 2 theta is 1, sin 90 degrees 1 because, and g is 9.8. So solving, we get u square is equal to 2 into 78.4. We can write it as 19.6 into 4 into 9.8. So this becomes 19.6 into 2 into 9.8 is again 19.6 into 4. So taking square root, we have u is equal to 19.6 into 2, which is 39.2 meters per second. In the next question, this is the figure, and in the first triangle we have tan alpha is equal to h upon x and tan theta is equal to h upon r minus x. On adding the two, we get tan alpha plus tan beta equals, take h common from the 2, we get 1 upon x plus 1 upon r minus x, which is equal to h common, LCM is x into r minus x, r minus x plus x is r, so therefore we get tan alpha plus tan beta is equal to hr upon x into r minus x. Also, see from the formula of equation of the trajectory of motion, we have y is equal to, on simplifying it becomes x tan theta times 1 minus x upon r, and since h comma x is a point on this trajectory, so put it is x comma h, so put y is equal to h is equal to x times tan theta times 1 minus x upon r becomes LCM is r minus x. From here, what we get, tan theta is equal to, on cross multiplying, it becomes hr upon x into r minus x. Now see the two values, these two, hr upon x into r minus x, same, so therefore tan theta is equal to tan alpha plus beta. Next problem. The ball is thrown horizontally from top of a tower with a velocity of 30 meters per second. During its motion, at a particular point, horizontal and vertical components of velocity are equal. Now, in a horizontal projectile, the velocity vector v is equal to u times I cap plus gt times j cap. that means its horizontal component is u and vertical component is gt. Now it is given that at a particular instant u is equal to gt. This implies t is equal to u upon g. U is 30 meters per second and take g to be 10, so we get 3 seconds. Next problem. The range of projectile when fired at 75 degrees to the horizontal is 0.5 kilometers. That means we have to use the formula of horizontal range on this one. R is equal to u square sine 2 theta by g. Now R is given to be 0.5 kilometers, that means 500 meters is equal to u square sine 2 theta. Theta is 75 degrees, so we have sine 150 degrees upon g. And what is the value of sine 150 degrees? It is sine 30 degrees, and sine 30 degrees is 1 upon 2. Therefore we get u square upon g is equal to 2 into 500, that is 1000. Now what will be the range when fired at 45 degree with the same speed? Means speed is same, then we have to find range. R is equal to u square upon g is 1000 times sine 2 theta, and sine 2 theta is sine of 90 degrees. Sine 90 degrees is 1, so we get R is equal to 1000 meters or 1 kilometer. Next problem. A body is thrown with a velocity of 9.8 meters per second, making an angle of 30 degrees. With the horizontal, it will hit the ground after a time. In this, we find the time of flight, and we have all the values given. T is equal to 2 times u 9.8 upon g is 9.8. Sine theta is sine 30 degrees 1 by 2, so it is coming out to be 1 second. In this question, a student is able to throw a ball vertically to a maximum height of 40 meters. Formula for maximum height is this one, and it will be maximum when theta is 90 degrees, that is h is maximum at, and its value is u square upon h, and r maximum is u square upon g. So h max upon r max is half, so r max is equal to 2 times of h, this is 2 times of 40 meters.